Solving AISL May 2025, paper 1, time zone 1 questions, and this is a question number 5. So let's make a short overview of this question. So this is a 7 marks total, and let's have a see given the diagram with a dolphin, and then there are 4 parts, 2, 2, 2 and 1 marks each, and it's given the function as well. Yeah. So let's see how it works. Let's start with the very beginning. A dolphin jumps out of water. The path of jump can be modeled by a quadratic function using the following variables. D is a horizontal distance from the point where the dolphin leaves the water, and h is the height of the dolphin above the surface of the water. So this is the h, and d is the distance, right? Okay, now let's turn to the question. In a particular jump, the dolphin first reaches a height of 5 above the surface of the water when the horizontal distance is 3, and again when the horizontal distance is 8.5. So what does it mean in the context of this problem? Dolphin reaches the height of 5.1 when the horizontal distance was 3, yeah? So this is a 3 and this is a 5.1, and again when the horizontal distance 8.5. So again means here 8.5 meters. Okay, so that's how it works. Okay, so we are talking about the height of 5.1. Okay, now write down the equation of axis of symmetry of the quadratic function. Axis of symmetry. So it's a bit unclear. How do we find the axis of symmetry if function is not given, right? What to do? Usually given either the equation of the function in the form of ax squared plus bx plus c with the x vertex, or axis of symmetry, which is the same for this case. It is minus b over 2a, right? Or it's given the p and q values zeros, yeah? So let's say that this is p and this is q. In this case, axis of symmetry could be found by finding the average of them, yeah? But you see, it is neither given. That's why we have to use the previous information somehow. If we will look at these 2 points, we can identify that they are symmetrical in the axis of symmetry. So this distance is equal to that distance, okay? It means that this point is actually midpoint of 3 and 4.5. So it is exactly in the middle. That's how we will use this to find the axis of symmetry. So axis of symmetry here is equal to, x is equal to 3 plus 8.5 divided by 2. So it is 11.5 divided by 2. It is 5.75. Okay, so the answer is 5.75, and there are 2 marks. Okay, now let's go to the next part. The quadratic function that models the dolphin jump is given. So now given the quadratic function where d is a positive and b is a constant, find the value of b. Okay, as I mentioned before, remember, we should find the connection between these two forms. Okay, and you see that it is actually the same. Now for this case, our a from this part, from this form, our a is equal to 0.2. A is equal to 0.2, and we should find b. And the axis of symmetry equals to minus b over 2a, right? It's actually what we wrote, minus b over 2a. And now from the part 1, we know that the answer is 5.75. 5.75. So 5.75, it's an axis of symmetry. 5.75. Okay, now everything is given, so we can plug, instead of a, we will put 0.2 here and then make calculations. Let's do that together. I will continue here. X is equal to minus b divided by 2 times 0.2 and equal to 5.75. Now we can solve for b. So minus b is equal to, let's multiply 5.75 times 2 times 0.5, 0.2. Okay, and then B will be equal to 2.3 minus B over 2A. Yeah, by the way, A is negative here. A is negative, so that is why our final answer is going to be positive. Yeah, let me just make short correction. Negative 0.2, yes. And now, if we will calculate, we will get 2.3. So B is equal to 2.3. C is our next part. So B done, A done, B is equal to 2.3. Now, find the horizontal distance when the dolphin re-enters the water. So we should identify what does it mean in the context of the problem. In the context of the problem, let me erase everything just to focus attention to the question of C part. So dolphin re-enters the water. Re-enters means that entering second time. This is the first time, this is the second time. Okay, and then we know that this point is x-intercept, or we can say that at this point y is equal to 0. So this point has a coordinates x and 0, right? So now let's use 0 for y, and we know the equation, so C part will be written here. So the equation of the height is negative 0.2 d squared plus 2.3 that we have obtained, so this is B, and we should equate it by 0. So our height here at this point is 0, so it is equal to 0. Okay, now let's solve this equation. Yeah, it's actually not B, it's G, yeah? It's G. Okay, let's solve this equation. Let's make D out of brackets. 0.2D plus 2.3 equals 0. So that's how we will get D1 is equal to 0, and let's solve for the second equation. That's how we will get negative 2.3 divided by negative 0.2, and it is 11.5. 11.5. So what does it mean in terms of the problem? So 11.5 is this distance, right? This distance, 11.5. 11.5. Okay, so next 2 points is yours. Last part, explain what a negative h value would mean in this context. Negative h value in this context. So negative h value we will obtain if we will continue path of dolphin, right? So it's let me show it is something like that here. So here at these points, our all point has a negative h coordinate, and we know that it is water. It is water, and how we can connect the fact that h is negative and situation in real life. I hope it is clear that the dolphin is underwater, or we can say that the dolphin is in the water. It's 1 mark, guys, so pay attention. It is only 1 mark. It should be answered shortly, and 1 mark calls R1 for reasoning. Okay, it was a question for the quadratic function modeling in real life, and let's go to the next question. See you in the next video.